All right, so Integrated 2, Chapter 12, Worksheet 1. School year is basically all but over. We go ahead and have a little bit of fun with stats. I'll tell you, these problems can get real tricky. I went out of my way to try and pick some that weren't so bad. But if you decide to take AP stats or take stats in college, I think you'll see how tricky statistics and probability can really get. But today we're going to focus on the fundamental counting principle, which we'll get to in a minute. But I just want to start with an easy tree diagram problem. We've dealt with these throughout the year, and here's just another example. So you go to the snack bar to buy a bagel and drink for lunch. You can choose from a plain bagel, a blueberry bagel, or a raisin bagel. The choice for a drink includes water or a sports drink. How many different lunches could be made from these choices? Well, again, you can have a plain bagel, you can have a blueberry bagel, or you can have a raisin bagel. So those are your three choices, and these are the bagel choice, right? And then from there, you're going to choose a drink. And in theory, it doesn't matter what kind of bagel you chose. Your choices are either water or a sports drink. And again, if we remember how to read a tree diagram, this says that we had a plain bagel and a sports drink. This says that we had a blueberry bagel and water. So that's just a quick reminder of a tree diagram, but you can see it says how many different lunches could be made. Well, this is one lunch, this is a second lunch, third, fourth, fifth, sixth. So it looks like there's 6 different lunches that I can make. But if you'll remember, these tree diagrams can get really big really quickly. So it's not always the best way. So there's something called the fundamental counting principle. And the fundamental counting principle is pretty cool. It basically says that if there's like 5 ways to do one thing, and there's 3 ways to do a different thing, then you can multiply them together, and there's 15 ways to do those 2 things. So for example, let's say you have 5 different shirts that you're choosing from, right? So you have 5 different ways of picking a shirt, and you have 3 different pairs of pants that you could choose. So what you would do is there's 5 ways of picking a shirt, there's 3 ways of picking a pants, there's 15 ways of choosing an outfit. You don't need to make that tree diagram with shirt 1, shirt 2, shirt 3, shirt 4, shirt 5, pant 1, 2, 3, pant 1, 2, 3, pant 1, 2, 3, etc. So that's the fundamental counting principle. So let's go ahead and take a look at a couple of examples of it, then we'll go back up to problem 1 to make sure that it works. And that'll be it. So a restaurant offers 4 sizes of pizza, 2 types of crust, and 8 toppings. How many different combinations of pizza with 1 topping are there? Well, like I said, we could say, oh, this is size 1, this is size 2, this is size 3, this is size 4. And then from there, we have crust 1 and crust 2, and make this giant tree diagram. But the fundamental counting principle says it's easier if we just say, look, there's 4 ways of choosing a pizza. Once I've chosen a pizza, there's 2 ways of choosing a crust. And once I've chosen a pizza and a crust, there's 8 ways to choose my toppings. So 4 times 2 is 8. 8 times 8 is 64. So there's 64 ways of putting this pizza together, which it grows pretty quickly, right? We're dealing with relatively small numbers over here, but you can see when we start multiplying them, we get a bunch of ways quickly. So 4 is a little bit different than 3. So 4 I want to do because you have, how many ways can we have 5 paintings lined up on a wall? So let's pretend this is painting 1, this is painting 2, this is painting 3, this is painting 4, this is painting 5, right? I have these slots over here. So on the leftmost slot, and then we'll call it left center, we'll call it center, and right. These are the 5 slots that I can put these paintings, right? Well, if I'm going to fill them out from left to right, I go over here, how many choices do I have for my first painting? Well, I have 5 choices. It doesn't matter which one I pick. Let's say I chose number 2. How many choices do I have for my second? Like the one that goes next to it in the left center spot. Well, I only have 4 choices now. So let's pretend I chose painting 4. Now in the center choice, well, there's only 3 choices left. So let's pretend I chose number 1. And what about right center? Well, now I'm down to 2 paintings. So let's pretend I chose painting number 5 there. And now there was 2 choices. And finally, once I've chosen these ones, this one has to be number 3. So how many different ways are there to line up 5 paintings? Well, 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. and 120 times 1 is 120. So there's 120 ways to line up these 5 paintings. If you don't believe me, get 5 kids and line them up. There's 120 different ways that you can line those 5 kids up. By the way, this is a factorial, which we'll talk about more in the next video. Now, like I said, we've done a couple of examples. There's obviously more in this worksheet that I'm going to leave for you. But I do want to jump back to number 1 and look at that first problem. And this time, instead of using the tree diagram, we'll use the fundamental counting principle. So you go to buy a snack bar and you buy a bagel and a drink. You can choose from plain, blueberry, or raisin. So there's 3 different ways I can choose a bagel. Then you choose a drink, water, or sports drink. There's 2 different ways I can choose a drink. So there you go. You can see that the fundamental counting principle does indeed verify what we learned in the tree diagram, that there's 6 ways of doing that. So fundamental counting principle, kind of a cool little shortcut to save you from having to make all these tree diagrams, but the application of it can be a little bit tricky. So, right, these were 2 totally different ways of applying the fundamental counting principle. So really think through and be careful what you're doing. I think what you'll notice in probability and stats is often the math isn't difficult, but what's difficult is knowing when you multiply, when you add, when you divide. That's when I always have trouble. And by the way, I'm not great at statistics and probability. It's easily the branch of math I do the worst with. So hope that makes sense. Feel free to ask some questions. Have a good day.